Okay, so we're talking about 1.4b here, which was antiderivatives of trig functions. So I'm looking over here at WebAssign, which is what I would like you to be working on while I'm not at school today. And so you've got antiderivatives and slope fields. And so you've got this pretty much this straightforward sine, cosine, tangent problems. I wanted to do number 3 with you really quickly. And you will have a slightly different problem than I do. So we're taking the antiderivative with the theta at the end, delta d theta. And so I'm going to break that into two integrals. We've got theta to the 8th for me, d theta, plus the antiderivative of secant squared theta d theta. And so for this part, this is just straightforward power rule. So I'm going to have theta to the 9th over 9, plus the secant is tangent theta plus c. And that's it, just to make sure that I'm correct. Let's go ahead and type that in. And so theta raised to the 9th divided by 9 plus tangent of theta. Using the symbols on the side, you can kind of see the box right there on the edge of the screen. And then, of course, plus c. Don't want to forget plus c. Don't want to lose points for not remembering c. And then I would hit submit. Looks like I might have some issues doing that. I don't really have a submit button. That's that. And so I would hit submit and check and make sure I was right. And then we have these 7 through 8 are your slope field problems. And they're not straight slope fields like what we were building, and they're actually drawn as curves instead of as slopes. They're not doing them as fields, even though they are doing fields because they're drawing them all. So they're asking for this particular answer. So what we're going to do is just do the antiderivative. So we're going to take our derivative and turn it into a differential, 2x minus 1 in parentheses dx. And then we're going to apply an integral to both sides. This side becomes y. This is x squared. 2 divided by 2 is 2. The 1 minus x plus c. And so, but then it wants it at the curve. So here's my general solution, and then I need a particular solution. So I know I have this point, 1, 2, and I'm going to go ahead and plug in. I know that when I plug in 1, I get out 2. So x is 1, y is 2. Go ahead and plug that in. So 2 equals 1 squared minus 1 plus c. So 2 equals 1 minus 1 plus c, or 2 equals 0 plus c, or just c. So c is 2. So what then I would plug into my function over here is x squared minus x plus 2. And that would be my answer. So it's fairly straightforward stuff here with your particular solutions. Find your antiderivative and then plug in the initial condition and see what happens. So scrolling down further, we have more particular solutions that I wanted to do. I think number 12. I thought 12 was very interesting and leave you to do 13. So 12 gives me a differential equation, but it gives me some very interesting things. It gives me the second derivative, which is also what I get on 13, and then an initial condition for my second derivative, and then an initial condition for my first. So I actually need to integrate twice. So my integral is going to be 6 dx, and when I take the integral of that, I get 6x plus, we're going to call this c1. And this is equal to f prime of x, because it's the integral of f prime. And so we take our condition here, where it tells me that f prime of 2 is 15. So I know x is 2, and my answer is 15. So 15 equals 6 times 2 plus c sub 1, which gives me 15 equals 12 plus c prime. And so 3 equals c prime. And so f prime of x equals 6x plus 3. Now I'm going to go ahead and take my integral again, second integral, 6x plus 3 dx. And again, this is all still for problem 12. I'm just going to cover this problem up so we don't have to think about it. Just get it out of the way so I'm not thinking about 13. There. Okay. And so taking the antiderivative, this is again the integral of f prime of x. And so I'm going to get f of x when I'm done equals 3x squared plus 3x plus c sub 2. I'm going to use my next initial condition to help me out. So I'm going to go ahead and plug in 2 again. And so I'm going to get 19 equals 3 times 2 squared plus 3 times 2 plus c prime, c sub 2. I know that's off the screen. Let me move it over. Oops. There. And so then I get 19 equals 12 plus 6 plus c sub 2. So 19 equals 18 plus c sub 2, which means c sub 2 equals 1. You'll notice that I used a different c there because they aren't the same. We talked a lot about how c's are always the same. This isn't. We have the c from the first derivative and the c from the second derivative, and so we're kind of trying to distinguish between them. So at this point now, I would go over here and type in my answer of f of x equals 3x squared plus 3x, and now plus 1 with my initial condition, and that would be my final answer. So it's pretty straightforward, all things considered, and good luck to you.